Good morning dear students, myself Sachin S. Pawar and I welcome you to my 13th video on Unit 5 States of Matter. In the present video, we will be discussing briefly some of the important concepts of liquid states. And the concepts which we will be learning briefly are: 1. Vapor phase, vapor pressure. Second one is boiling point. Third one is surface tension. And the fourth one is viscosity. And we will learn these all in brief, because the Karnataka syllabus has reduced, they don't want you to learn in detail about these. So we will learn these one by one in brief. So let us first go for the vapor pressure of the liquid. We will first go for the vapor pressure of the liquid. Okay. So what is vapor pressure of the liquid? Okay. For this, let us choose one container. Okay. I'll just take one container. In this container, what I'll do is, this container I will close. I'll take a closed container. I'll take one closed container. Okay. In this closed container, what I'll do is I'll take some liquid particles. Okay, I'll take some liquid. I'll take some liquid particles in this. You take water, whatever it is. Now at any specific temperature, you will see that on the surface whatever particles are there, those particles have a tendency to move out of the surface. They move out of the surface and they want to wander in this empty space. And when they go out of the surface and they wander elsewhere, the gap between these particles will decrease, and when the gap between the particles decrease, their intermolecular forces decrease, they get converted into a gaseous state, and this gaseous state of the liquid is known as the vapor state. So here what is happening is the liquid is converted into vapors. This process is known as vaporization, and this happens at any specific temperature. At any temperature, some kind of evaporation is still there. Now what I have done is, I have restricted those vapors not to go elsewhere, so they will collide on the wall and they have to return back. They have to get returned back to the surface, and when they return back, it is found that the vapors now get condensed into liquid. They get condensed into liquid. This is called as condensation. So in this container, two processes are ongoing. One is liquid is converted into vapor, that is vaporization, and the vapors formed will combine together, will collide with one another and form the liquid, and that is condensation. After some time, you will see that the process of vaporization and condensation counterbalance each other, and the amount of vapors formed remains constant. This is called as equilibrium stage. So at equilibrium stage, vaporization process also is taking place, condensation process also taking place, but at specific both are happening at same speed. That means the number of vapors formed on the surface of the liquid are constant. At this stage, if you just find out with what force these particles of the vapors are colliding on the wall, that force acting per unit area is called as pressure, and this is known as the vapor pressure. So vapor pressure is defined as the pressure exerted by the vapors in equilibrium with the liquid on the walls of the container. So just I'll take this definition. the definition goes like this. This is the definition. What do you mean by vapors? Okay, so what is vapor pressure? The pressure exerted by the vapors on the walls of the container in equilibrium with the liquid. In equilibrium with the liquid. So they should be in equilibrium with the liquid. When they are in equilibrium with the liquid, that time when they are in equilibrium with the liquid, they exert pressure. They should be in equilibrium with the liquid. So I hope you have understood. The pressure exerted by the vapors in equilibrium with the liquid. In equilibrium with the liquid, but that should be at a specific temperature. Why at a specific temperature? Because if the temperature is increased, the vaporization will increase. Okay, so the vapor pressure need to be defined at a specific temperature. At a specific temperature. That is the definition of vapor pressure. Right. So with this knowledge of vapor pressure, let us move into the next aspect, that is the vaporization and boiling. Vaporization and boiling. Okay. So we'll go for, or I'll just cancel all this. Okay. So vaporization or boiling. Okay. What is boiling point now? Boiling and vaporization. Okay, if I ask you what is the boiling point of water, you will say it as 100 degrees Celsius. What do you mean by that? It is the temperature at which the entire liquid gets converted into a gas. The entire liquid gets converted into gas or vapor. Converted into gas or a vapor. What is vaporization? Vaporization is at any temperature, surface particles, the surface particles of the liquid are converted into its vapor or in the gaseous state. So when I say vaporization or boiling, they are of different concepts. Boiling is taking place at specific temperature, whereas vaporization take place at any temperature. Boiling means the entire liquid gets converted into gas, that is, it is a bulk phenomena. It is a bulk phenomena. It is the bulk phenomena. Okay, whereas vaporization, when I say, it is a surface phenomena. It is the surface phenomena. Surface phenomena. So I hope you have understood difference between the boiling and vaporization. Boiling means at a specific temperature, entire liquid gets converted into gas. So it's a bulk phenomena. Whereas at a specific at any kind of a temperature, even in normal conditions of temperature and pressure, surface particles have a tendency to go into vapor state. That is called as vaporization. So a question of in the examination, you may expect a question of 2 marks, distinguish between vaporization and boiling. I hope you have understood this. Okay, now let us move into the boiling point. I say boiling point of water is 100 degrees Celsius. Okay, now you are okay, I ask you a question. So by the previous knowledge, you will say boiling point of water is 100 degrees Celsius. That is a temperature at which the liquid water gets converted into the water vapors. Liquid water gets converted into water vapors. Now when I say the boiling point is of 2 main types as far as our syllabus is concerned. Boiling point. When I say boiling point is defined as the temperature at which the temperature at which the liquid gets converted into gas. Now when a liquid gets converted into gas means it is forming a gas, and gas. So actual definition is the boiling point is the temperature, boiling point is the temperature at which the vapor pressure of the liquid becomes equal to the pressure of the atmosphere or atmospheric pressure, that is pressure of the surrounding, atmospheric pressure. Boiling point is the temperature at which the vapor pressure of the liquid becomes equal to atmospheric pressure. This is the definition of the temperature. This is the definition of the boiling point. But now, since we have learned this unit and we know that atmospheric pressure can be expressed in different units, we may express it in 1 atmosphere, we may express it in 1 bar, we may express it in 1 atmosphere, that is equal to 10 to the power 101,325 pascals, or this is 10 to the power 5 pascals we can express. So depending upon which unit we are using, we have two types of boiling points. One is called as normal boiling point, another is called as standard boiling point. Standard boiling point, normal boiling point and standard boiling point. Normal boiling point is the temperature at which normal boiling point I am talking about, at which the vapor pressure of the liquid becomes equal to 1 atmosphere, and standard boiling point is the temperature at which the vapor pressure of the liquid becomes equal to 1 bar. So we have two here. Now if you just check, 1 atmosphere is 101,325 pascals and 1 bar is 10 to the power 5 pascals. That means 1 bar is less than 1 atmosphere. 1 bar is less than 1 atmosphere. So definitely the standard boiling point will be less than the normal boiling point. And therefore if you just say, when I say the boiling point of water is now for example, for water the boiling point is, normal boiling point is 100 degrees Celsius and standard boiling point is 99.6 degrees Celsius. 99.6 degrees Celsius. What do you mean by that? This means that at 100 degrees Celsius, what happens? The vapor pressure of water, liquid water, becomes equal to 1 atmospheric pressure. And when I say the boiling point of water is, the standard boiling point of water is 99.6 degrees Celsius, it means that the vapor pressure of liquid water has become equal to 1 bar pressure. So these are the definitions of normal boiling point and standard boiling points. So this is a brief information regarding the boiling point. Boiling point is the temperature at which the vapor pressure of the liquid becomes equal to the vapor pressure in the atmosphere, in the surrounding. And as we are taking 1 atmosphere and 1 bar as a standards, normal boiling point is the temperature at which the vapor pressure of the becomes equal to 1 atmospheric pressure, and standard boiling point is the temperature at which the vapor pressure of the liquid becomes equal to 1 bar. One example, for water the boiling point, normal boiling point is 100 degrees Celsius, standard boiling point is 99.6 degrees Celsius. That's it. With this, let's move on to the next aspect, that is surface tension. For this I need to clean this screen, so I'll just clean the screen. Now we'll move on to the next aspect, that is surface tension. Okay, before I move on to the surface tension, I would like to bring it to you some important observations which we have done. Okay, so I have just brought some observations for you. These are from your government text. Okay, so these observations you have already done. A small drop of mercury forms a spherical bed instead of a spreading on the okay, if you take a mercury drop and if you drop it on the glass, you will see that it won't spread. It won't spread like a normal liquid. It won't spread, but it will form a it will form a spherical bed. It will be like a bun. It will have a shape like a bun. It will have a shape like a bun. Like for example, it will on the glass surface, it will appear like this. Mercury will appear like this. A drop of mercury will appear like this. Why it will show a spherical bed instead of spreading? One more question. A particles of a soil, if you just go near the sea or river, if you just go near the river, particles of the soil at the bottom of the river remain separated. You will see, if you put your hand in the river, if you put hand in the river and if you just see, you will see the particles in the soil, particles of the soil in the river, they are separated. But the moment you just take them out, you will find that they stick to each other. They stick to each other. Why? One more answer, one more question, one more observation. A liquid rise or fall in a thin capillary. Just take one, okay, just take, you have a, what we call as, okay, you drink soft drinks. Okay, so you have that, what it is called, straw. You have a straw. Okay, if you just take a straw, okay, and just dip it in Coca-Cola. If you just dip it in Coca-Cola, you will find that the Coca-Cola rise of its own in that. This is called as capillary motion. It is thin capillary. I am just giving an example. So there will be a rise in the, so that liquid will, that Coca-Cola will rush into that straw. And if you want to check it, put that straw into the water or into any liquid and just put your finger onto the top of the straw and just lift it off. You will see some liquids has entered into it. Why? All these questions, the answer for this is, all this is happening because of surface tension. All this is happening because of surface tension. So you should know that all these phenomena which are happening, they are happening because of none other than they are happening because of surface tension. So you should know what is surface tension. So let us begin with surface tension. Okay, what do you mean by surface tension? What do you mean by surface tension? Okay, surface tension. Now for this, understand, it is a tension on the surface. Now tension on the surface, okay, let us understand this. Okay, so suppose I have a liquid in the container. Again I will take a container. I will take a container, in that I will take some liquid. I am just taking some liquid in the container. Okay, so I have just taken one liquid in the container. Okay, now for this, let us choose two liquid part. Okay, this is the surface of the container I'll just take, okay, this is the surface of the container, surface. Okay, I'll just choose one liquid at the interior part and one liquid particle at the surface. Okay, at the surface, at the surface. Now you know whether it is solid, liquid or gas, we have what we known as intermolecular forces. We call them as van der Waals forces. So here this particle in the interior have got the interactive force or the attractive forces operated in all possible directions, like this. Correct. So the molecule which is sitting in the interior part of that container, liquid, interior part of the liquid, it will be pulled this side also, it will be pulled this side also, it will be pulled up also, it will be pulled down also, it will be pulled this side, it will be pulled down, it will be pulled in all possible directions. And since it is equally pulled in all possible directions, it will not feel that it has been pulled elsewhere, because it's the attraction on this side is cancelled by the attraction on this side, and so on, the opposite attractions cancel. But when the particle is about to hit the wall, and this particle, when I am talking, then you will find that it also will face some forces, but these forces will be inward forces only, because there are no particles, above it, on the surface. Above the surface there are no particles. So the particle which is on the surface has got the forces of attraction on this side. Now this forces on the surface cancel, these forces cancel, but however these forces make this particle to sink in. This particle make the particle to sink in. This force acting on the surface of the liquid, this force acting on the surface of the liquid, perpendicular force, this is the perpendicular force acting on the surface of the liquid, is known as surface tension, is known as surface tension. So what is surface tension? I hope you must have understood. Right. So surface tension, what is surface tension? I hope you have understood. Right. Okay. So if I just have to go for a definition of that, then what is surface tension? The simplest definition of surface tension is, here. Surface tension is defined as the force acting per unit length. This is the length of the, okay, see, this is the length, surface length. So surface tension is the force acting per unit length. So I will just take a unit length, per unit length, perpendicular on the line drawn on the surface of the liquid is known as surface tension. And you know the force, unit of force is Newton, acting per unit length. Unit of length is meter, so SI unit of surface tension is Newton per meter, and the symbol for surface tension is nu, and therefore the SI unit of surface tension is Newton per meter. This is surface tension. Right. So this is the brief idea regarding surface tension. Now let's quickly move on to the last part of the topic, that is viscosity. Viscosity. Okay, viscosity. Okay, for this I'll just take two types of examples, two types of liquids. I'll just take liquid one. Liquid, say I have taken, say, some examples of liquids. Let me take water. I'll take one example, or alcohol, for example. Okay, I'll just take another type of a liquid. Another type of liquid, say I have a glycerine, or say I have some kind of a oil, okay. Now if I have a slanting table here, okay, I have a slanting table, okay, I have a slanting table here, okay, and what I'll do is I'll just drop a liquid water onto this, a drop of water onto this. What's going to happen? This water particle will slant, this water particle will slide down and it will fall down. The water particle will slide down and fall down. So similarly, I take water, suppose I'll take a drop of oil here, a drop of oil. Now this oil, and if I just take a drop of water, the water will slide faster compared to oil. So oil is going to show some resistance to the flow. So some liquids are going to show some resistance to the flow, This resistance to the flow of liquid is known as viscosity. Resistance to the flow of liquid is known as viscosity. I hope you have understood this. Okay, so definition of viscosity, I am just dragging it onto the screen. So what is viscosity? If I ask, then viscosity is nothing but the property of the liquid which determines the resistance to the flow of liquid. The property of the liquid which is deciding the property of the liquid which is deciding the resistance to the flow of liquid is known as viscosity. The property which determines the resistance to the flow of liquid is known as the viscosity of the liquid. Okay, viscosity of the liquid is usually determined in terms of okay. So viscosity is usually determined in terms of a unit known as okay, so we have one viscosity that is known as the coefficient of viscosity. One term you need to understand or remember, that is the coefficient of viscosity. The coefficient of viscosity is symbolized as eta. Read this as eta. So what is this coefficient of viscosity? The definition, I will just drag it onto the screen. Coefficient of viscosity. So this is coefficient of viscosity. The definition goes like this: viscosity is the force when the velocity gradient is unity. and the area of the contact is unity. So here the particle is moving. Okay, so here when the particle is moving on the surface, okay, so the area of contact should be unit area, okay. The particle should be having the unit area of contact, and the velocity with which it is moving should be unity. The velocity should be unity and the area of contact should be unity. In that case, that is called as coefficient of viscosity. Symbol is n. Actually the viscosity, the force of viscosity is determined by a formula. That formula I am not going to explain in detail. That formula goes like this. The formula is the force of the viscous force. The viscous force F is equal to coefficient of viscosity into area of contact into the velocity upon the length of movement. So if I just find out that, then coefficient of viscosity N is equal to force into L upon A into V, where force, unit of force is, now SI unit I am talking about. So if I just find out the SI unit, force is Newton, length is meter, upon area is meter square, into velocity is meters per second. So this unit of viscosity, coefficient of viscosity becomes Newton, meter cancels, seconds per meter square. This is the unit. Newton seconds per meter square is the unit of coefficient of viscosity. So this completes the topic unit 5, states of matter. Okay, before I say it is complete, there is one more last part is remaining that I will take and I will stop. That is known as the laminar flow. There is one more last concept which has to be taken, that I will take and I will stop. What is known as the laminar flow. What do you mean by this? Okay, for this what I'll do is I'll just take one surface. Okay, on this, suppose I am just taking some liquid particles. Okay, so liquid particles, suppose are forming different layers here. So I'll just take 3 layers of particles. Okay, right. What I'll do is, on this liquid, now this is the liquid, this is the liquid I have taken in the container. I have just taken it on the surface. This is a surface, metal surface, you say it is a metal surface, and on this liquid I'll just drop a wooden plate. Okay, I'll just drop some wooden plate. Now this wooden plate, when it is allowed to move in one direction, say it is moving in this direction. Okay, it is moving in this direction. You can you can't observe this. So here, when this wooden sheet is moving in one direction, the surface below this whatever liquid particles are there, these liquid particles also will move. Suppose they are okay, so again below that also they are going to move, and this process of, so in the layers, the liquid particles in different layers will start moving. Suppose the velocity of this is v, the second layer is v, then these will move faster because of this force, because of the force of this wood, and there you will find that this layer this layer and this layer, different layers of water particles will move with different speed, will move with different speed. So with the moment when they approach here, you will see, suppose this particle is moving, suppose this layer is moving, okay, it is moving, then you will see this layer will move with it, this layer will move with it, I hope you are understanding what I am doing here. Okay, but the lower layer which is there, it will move with a little bit lower speed, and it will be lagging behind, in certain, so it will be little bit behind in movement, it will be little bit behind the movement, in the movement it will be little bit behind. Okay, so I hope you have understanding, or rather I'll just say this laminar flow means what, I'll explain you again and I'll stop. Laminar flow. Okay, so suppose I have a surface, and the particles are, this is the first layer of particles, and this is second layer of particles of liquid, then third layer of particles of liquids, and so on. Okay, so on this surface I just take one wooden rod, suppose, or wooden plate I take, and it is allowed to move in one direction. Then you will find that this is, when it is moving, okay, the first layer will move, with same speed. All these layers of these are not going to flow with same speed, they are not going to move with same speed. The first layer will move with a little bit of higher speed. Suppose this first layer, this layer is moving with a velocity v, this will move with velocity v plus dv, this will move with v minus dv. So all these layers, layer 1, layer 2, layer 3, all these layers of particles will be moving along with this at a different speed, and this is called as the gradation velocity, regular gradation in velocity, that is gradual increase in the velocity. This is lower velocity, this is a bit higher velocity, this is more higher velocity, and so on. So the layers in the water, they will be moving with different speeds, The first layer which is in touch with that wood will move bit faster. Below that layer of water particles are there, they will move bit slowly compared to the one which are in touch with the wood. Again, and so on, the process is there. So the particles are moving with different speeds. So there will be speed means velocity. So there will be regular gradation in the velocity. And this, because of this regular gradation, the flow of the liquid is a laminar flow. It is laminar flow. It is called laminar flow. What do you mean by laminar flow? Laminar flow is this. Okay. Laminar flow, the type of the flow in which there is a regular gradation of velocities, regular gradation of velocities passing from one layer to the other layer, passing from one layer to the other layer. So the first layer which is in contact with the wood will have to move faster, will be moving faster. The one layer of liquid particle which is below it will be moving little bit slower speed, and so on and so on. The lower levels will be moving with different speeds. And if you go if you go to the very deep level, you will see that water is not moving at all. That water layer is not moving at all. So there will be regular gradation of velocities, regular gradation of velocities. Suppose there is one ship is moving. The water particles below that ship will be moving with some particles. They will be moving with some, and that moving with some velocity. Those particles which are below the level layers, they will be moving with certain velocity, and the velocities of all those layers will be different, and there will be regular gradation, regular decrease in the velocity. And if you just go in deep, there is no movement at all. This is regular gradation. Therefore it is called as laminar flow. And this completes the topic unit 5, states of matter, gases and liquids. You have any questions to ask, you can ask me in the Google Classroom. I'll be able to answer it, or you can call me. Some of you have my mobile number, you can directly call me also, or you can mail me. I'll be able to explain your difficulties. Thank you.